Today we're looking at systems of quadratic equations. There are some things you need to be able to know by the end of this. One, you need to describe what you're looking for when you solve a system of equations. You're going to be able to use the substitution methods to solve systems of equations containing quadratic equations. And you're going to be able to use linear combination methods to solve systems of equations containing quadratic equations. Now here it says just solve the system of equations. What you're looking for is where these two objects intersect. Here we've got a line in the first one. Here, this is a line. And this is a parabola. We're looking for where the line and the parabola intersect. So what we're going to do is take, since y equals x, I can substitute y in for x. Sorry, x in for y. So, x equals x squared. Now in order to solve this, I need to move everything over to one side and set it equal to 0. So 0 equals x squared minus x, and we can factor this. 0 equals x times x minus 1, and this gives us two values, x equals 0 and x equals 1. Now that I have those two values for x's, I need to figure out what y is. If I plug these numbers into the first equation, y equals 0 if x equals 0, and y equals 1 if x equals 1. So we get two answers, the point 0, 0, and the point 1, 1. These two shapes intersect at 0, 0, and 1, 1. Now let's do something a little more complicated. Let's take the second equation and make it y equals. Now if I want to make it y equals, I'm going to subtract the 2x from both sides and get negative 2x minus 1. Now I can take this value for y and plug it into the first equation. We get 4x squared plus negative 2x minus 1 squared equals 25. Now I should be able to solve this equation for x. So what I've got now is 4x squared. Next, multiplying this out properly, 2x squared, or negative 2x squared, become positive 4x squared. The middle term, if we're foiling it out properly, is negative 2x minus 1, so that's plus 2x plus 4x. Negative 1 times negative 1 is positive 1. And that equals 25 still. Simplifying this now even further, 8x squared plus 4x. Just move the 25 over by subtracting it, we get negative 24 equals 0. We can divide everything by 4. 2x squared plus 1x minus 6 equals 0. And this is factorable. The factors become x plus 2 and 2x minus 3. So x equals negative 2, x equals 3 halves. We then plug these numbers into that second equation to get our y values out. And we get y equals, if x is negative 2 times 2 is negative 4. Add the 4 over, y equals 3. 3 halves times 2 is 3. Subtract the 3, we get y is negative 4. So we've got 2 points, negative 2, 3, and 3 halves, negative 4. That's the substitution method. You rewrite one of the equations so that you get one of the variables by themselves. Then you take that value and plug it into the other equation. Solve for one of the variables, and then you can take those numbers and plug it in and solve for the other variables. If we want to use the linear combination method, we have to use equations where they're both quadratics. So here we've got x squared plus y squared equals 16, the circle, and x squared minus y squared equals 20, which is a hyperbola. Now since both x squared and y squared are squared, then we can use linear combinations. So if we just add these two equations together, we get 2x squared equals 36. And we want to divide both sides by 2, so we get x squared equals 18. Which means x equals positive and negative, the square root of 18 is 3 square root of 2. Since we know x squared is 18, I'm going to use that to plug into the equations. And I'm going to plug into that first equation. We get x squared plus y squared equals 16. 18 is x squared plus y squared equals 16. Y squared equals negative 2. So that means that y would be plus or minus I rad 2. Now when we're solving systems of equations, we want real solutions only. Since we've got this imaginary number here, we don't have real solutions, so we write no real solutions. And that becomes our answer. One last example. If I'm going to do some work here, I need to get either the x's or the y's to cancel out. So what I'm going to do is I'm going to multiply this first equation by negative 3. The reason I'm using negative 3 is so that I can get the y's to cancel out and try and work with the x's. If I do that, I now have two equations, negative 3x squared minus 3y squared equals negative 21, and 4x squared plus 3y squared equals 24. Now we can add these two equations together. So we get negative 3x plus x squared plus 4x squared is x squared. The 3y squareds cancel out, and negative 21 equals negative 21 plus 24 is 3. So x equals positive and negative square root of 3. And we could take that x squared, we'll plug it in back to one of the original equations. In this case, x squared plus y squared equals 7. So 3 plus y squared equals 7. Y squared equals 4. So y is positive and negative 2. And now we have 4 points. We've got the square root of 3, comma 2, square root of 3, comma negative 2, negative square root of 3, comma 2, and negative square root of 3, comma negative 2. And in this case, these two shapes, circle and an ellipse, intersect at 4 different places.